So hello to all, my name is Anita. Welcome to our magic tutorials for chemistry. So today we are going to see the lab preparation for oxygen. So the lab preparation for oxygen, the first method is catalytic decomposition of potassium chlorate. Correct? So catalytic decomposition, that means in the presence of a catalyst. So check the reaction. Potassium chlorate, KClO3. Correct? Potassium chlorate, the formula is KClO3. So potassium chlorate heated in the presence of a catalyst, that is manganese dioxide, MnO2, at 420 Kelvin temperature. Correct? It produces KCl, potassium chloride, and oxygen. Correct? So this is the first lab preparation of oxygen, that is potassium chlorate in the presence of a catalyst manganese dioxide. It is heated at a temperature of 420 Kelvin temperature. It produces KCl and oxygen gas. We will write here G because it is in the gaseous form. Correct? In the presence of this catalyst, okay, oxygen is produced quickly. Okay, but in the absence of this catalyst, it takes many years to form this oxygen. So this is the first preparation. We will balance the equation. So I will write here 2, here also 2, and here 3. Correct? So the equation is balanced. Let's check the next reaction. The next reaction is decomposition of metal oxides. Correct? I will take the example of HgO. Metal oxides, decomposition of metal oxides, PbO2. Decomposition of metal oxides, we know mercury, Hg mercury oxide, and PbO2 lead oxide. So thermal decomposition, that means what? Heating, right? Heating it, so that is called as thermal decomposition. It produces Hg and O2 gas. Correct? So just to balance the equation, I will write here 2, here also 2. So thermal decomposition. Decomposition means we know it will split, right? The compound will split into small molecules or small. So PbO2 on thermal decomposition, it forms PbO plus O2 gas. Correct? Balancing the equation here, I will write here 2, I will write here 2. So 2 2s are 4 oxygen, here 2 oxygen, here 2 oxygen, Pb is 2, Pb is 2. Thermal decomposition means decomposition in the presence of heat. So this is the second preparation, that is a lab preparation for oxygen. Just make a note of these two equations. So the third preparation is decomposition. Again it is a thermal decomposition of hydrogen peroxide, H2O2. Thermal decomposition of hydrogen peroxide, that is H2O2, in the presence of a catalyst, that is MnO2. Again the same catalyst, MnO2. This H2O2, it is in the aqueous form. Okay, thermal decomposition, so I will put a heat symbol, small triangle, that is a heat symbol. So thermal decomposition of hydrogen peroxide, it produces water and O2 in the gas form. O2 is in the gas form, water in the liquid form. Balancing the equation, 2 I will write here, 2 I will write here. So 2 oxygen, 4, 2 2s are 4, 4 hydrogen, balanced. Correct? So these are the lab preparation of dioxygen. Correct. Now let us check the industrial preparation. Industrial preparation. So industrial preparation, it is prepared by two methods. The first one is electrolysis of water. Electrolysis of water. And the second preparation, that is separation of components of air. Separation of components of air. So these are the two methods used to produce dioxygen. That is the industrial method. By electrolysis of water, where we get hydrogen and oxygen will be produced using the electrolysis, that means in the presence of electric current, what will happen? The water will split into hydrogen, oxygen. Second method is separation of components of air, correct, where we are passing it through the distillation, fractional distillation, and then nitrogen it is separated, oxygen is separated, argon gas is separated, correct, because air consists of these gases. So these are the two industrial methods of dioxygen. We will move to the next, that is the properties of dioxygen. Just make a note of this. So we will see the properties of dioxygen, correct, physical properties. So I just written some numbers, I will explain you. So the first point, the property of dioxygen is, it is colorless, correct, it is colorless, odorless and tasteless, correct. Oxygen is present in the air, correct. If it is colored gas means you can see oxygen over here, but it is colorless, it has no color, it is odorless also, no smell and no taste also, correct. Okay. So its density, it is 1.42 grams per liter density, and it is heavier than air. Third point is its melting point, MP, that is a melting point is 54.3 Kelvin temperature. Fourth point, boiling point is 90.18 Kelvin temperature. Now it exists as solid, liquid, gas. Dioxygen can exist as solid, liquid, gas, but depending upon temperatures and pressure. T and P, that is temperature and pressure. So these are the physical properties of dioxygen: colorless, odorless, tasteless. Its density is 1.42 gram per liter and it is heavier than air. Third point is melting point is 54.3 Kelvin, boiling point is 90.18 Kelvin. It can exist in all the three forms, solid, liquid, gas, depending upon the temperature and pressure. So these are the physical properties. Now let's check some chemical properties of dioxygen. So dioxygen, it will react with the metals, correct. The first chemical properties means the reactions. So it will react with the metals. I'll take sodium metal, O2, and it will form oxide, correct. Check for the formula, children. Here sodium oxide it is forming, but you should know the formula, how to write, crisscross method, correct. Two elements combining, sodium oxide. Sodium, the valence is +1, oxygen it is -2, crisscross, Na2O1, O1 we are not writing. So it is Na2O. So sodium, that is a metal. So oxygen can react with a metal and it can form oxide, metal oxide. Here we have taken the example of sodium, it is sodium oxide. The nature of the metal oxides, will be basic. Always metal oxides, they are basic in nature. Let's check the next reaction with non-metals. So non-metals, a simple example, carbon, which is a non-metal solid, plus O2, G, that is a gas form. What it will form? Carbon combines with oxygen, it will form CO2. Correct? Again it is a gas. CO2 gas it is forming. Now the carbon dioxide which is formed, correct, it is a non-metal oxide. Non-metal oxides, they are always acidic in nature. They are acidic in nature. Correct? So these are just the reactions I have given. You can also write the equations with other elements, other metals and non-metals also. Correct? So third one, dioxygen, it is paramagnetic in nature. It is paramagnetic in nature. So dioxygen, it is paramagnetic in nature. Paramagnetic means what? Presence of unpaired electrons. Okay. Presence of unpaired electrons. Dioxygen, it does not react with acids and bases. It does not react with acids and bases. It does not react with acids and bases. Just make a note of these points. We'll discuss the next points. Yes, so the last point we discussed, that is oxygen does not react with acids and bases. So what is the reason? Because oxygen, it is a non-metal. Correct? So it will not react with acids and bases. So let's check the next point. Oxygen, that is I think the fourth point. So oxygen will react with any hydrocarbon compound. Correct? Hydrocarbon compound means compounds which are having hydrogen and carbon. Organic compounds, right? Like methane, ethane, propane, ethene, ethine. They all are hydrocarbon compounds. So I'll just write the example of CH4, methane. It's a hydrocarbon compound. So oxygen will react with methane. It will undergo what? Combustion. Correct? It will undergo combustion and it will produce water and carbon dioxide. Now always remember, any hydrocarbon compound, if it reacts with oxygen, any hydrocarbon compound, propyne, butane, heptane, pentane, correct, they can react with oxygen and it will form water and carbon dioxide. Correct. The next one, oxygen which is present in the air, it will combine with the moisture present in the air and it will react on the iron substances, right? On the iron substances. So I'll write it as Fe, iron, plus O2, that is oxygen, and the moisture present in the air. Why I have written G? Because it is a vapors, right? Moisture present in the air and it will form Fe2O3 X molecules of water, that is iron oxide. You can also write it as hydrated iron oxide because it is hydrated in the form of water. Correct? So iron, it is attacked by the oxygen and moisture present in the atmosphere and it forms Fe2O3, that is iron oxide, and some molecules of water will be attached. That is what? Rust. And this is what? Rust. You know what is rusting, right? Rusting of iron substances. So here we complete with the properties of dioxygen. Correct? So we have completed with the preparation and properties of dioxygen. The first question is, noble gases do not react with oxygen, or oxygen do not react. There is no reaction between oxygen and noble gases. So that is the first question. The second question, noble metals, they are not attacked by oxygen. Again the same question, oxygen does not react with the noble metals. I'll tell you what is noble metals. And the third question, I have given 4 elements here: zinc, titanium, platinum, iron. Okay, my question is, out of these 4, which will not be attacked by oxygen? Which will not react with oxygen? That is my question. Okay, and one hint I will give here is, the first row of the D block elements, the first series of the D block, that is 3D series, the elements will be from atomic number 21 to 30. Okay, starting from scandium up to zinc. These elements, they react with oxygen. Other elements will not react. That is a hint given to you. So let's discuss the answer. So oxygen will not react with noble gases. Why? Noble gases means what? Their octet is complete. Correct? Their octet is complete. We'll take the example of argon, helium, neon, argon, krypton, xenon, radon. Correct? They are the noble gases which come in the 18th group in the periodic table, and their octet is complete. What do you mean by octet? Means the valence shell, it is having 8 electrons. So argon, the atomic number is 18. Electronic configuration, we write it as 2,8,8. Correct? So you can see the valence shell, it is completely filled. 8 electrons in the valence shell, octet is complete, and because of this octet complete, it is inert in nature. Inert in nature. Correct? And moreover, they do not accept any electrons to complete the octet, because their octet is already complete. They are not accepting any electrons. So they are also called as zero group elements. Group number 18. We are talking of group number 18 in the periodic table, right? So what is the reason? Oxygen does not react with noble gases. Why? Because noble gases, their octet is complete. They are inert in nature. Okay. Noble metals means what? Noble metal means the metals which do not react with oxygen. And which are those metals? The ornaments which we wear, right? So noble metals, they are the gold, Au, that is gold. Then I can write platinum, correct, Pt, and silver, Ag. Silver will react because it tarnishes in the air, I'll tell you that. But they are said to be the noble metals because they do not react with oxygen. Correct? So Au, Pt, Ag, they are called as the noble metals. They do not react with oxygen. What is the reason? One word reason. Because they are very less reactive. These metals, noble metals, they are less reactive. Less reactive. How did we find that they are less reactive? Because in the metal reactivity series, they come to the bottom. Correct? They are at the bottom in the metal reactivity series. Correct? Which is on the top metal reactivity series, that will be most reactive. Which comes to the bottom, that is least reactive. So because of less reactivity, noble metals such as Au, Pt, Ag will not react with oxygen. Okay. Next one. Yeah, I want to tell you about silver. Silver, it will tarnish, correct? That is in presence of traces of oxygen. It It is not like completely oxygen is making the silver to tarnish. Correct? If you wear some silver anklets or bracelets and all, you can see it will tarnish. It will get a black surface on it. What is the reason? It is tarnishing because of the presence of traces of oxygen and mostly because of the sulfides present in the atmosphere. Okay, let's discuss the third question. Out of these elements which will not react with dioxygen, so I gave you a hint that atomic number 21 to 30, these elements will react with dioxygen. Correct? So 21 to 30, if I say, the elements are scandium to zinc. Correct? Scandium to zinc. So how to remember? Scandium, that is 21 atomic number, titanium 22, 23 is vanadium, 24 is chromium, 25 is manganese. Correct? Then it comes FeCONi, that is Fe iron, 26 is the atomic number, cobalt 27, Ni, that is nickel 28, and copper, zinc. Correct? So I have written here 21 to 30 elements. How to remember this? Scati, Vikraman, Feconi, copper, zinc. Scati, Vikraman, Feconi, copper, zinc. That way you can remember. So now can you find zinc is coming in 21 to 30? Yes, it is coming. Titanium is coming? Yes, it is coming. Platinum? No. Iron? Yes. So what was the hint given? The element which belongs to 3D series, that is the first row of the D block elements, they will react with oxygen. Others will not. So which is not coming here? Platinum. So which is the odd one out? Platinum. So platinum will not react with dioxygen. What is the reason again? It is a noble metal, right? It is a noble metal. That is the reason. Correct? That was a hint given to you how to find it out. But the actual reason is it is a noble metal. So it will not react with oxygen. Otherwise we know if we are wearing gold, platinum and all, it will not tarnish. Correct? The color of the gold and all will remain as such. Okay. So these are the questions can be asked as MCQs. So hope you have made a note of it. So in the next video, I will upload about the ozone, its preparation and properties. Thank you all.